In this video, you'll learn how to find the probability of two independent events or two dependent events, and find the probability of two mutually exclusive or inclusive events. How are probabilities used by meteorologists? The weather forecast for the weekend calls for rain. By using the probabilities for both days, we can find other probabilities for the weekend. What is the probability it will rain on both days? Only on Saturday or on Sunday. A single event, like rain on Saturday, is called a simple event. Suppose you wanted to determine the probability that it will rain on both Saturday and Sunday. This is an example of a compound event which is made up of two or more simple events. The weather on Saturday does not affect the weather on Sunday. These two events are called independent events because the outcome of one event does not affect the outcome of the other. If two events, A and B, are independent, then the probability of both events occurring is the product of the probability of A and the probability of B. Roberta is flying from Birmingham to Chicago to visit her grandmother. She has to fly from Birmingham to Houston on the first leg of her trip. In Houston, she changes planes and heads on to Chicago. The airline reports that the flight from Birmingham to Houston has a 90% on-time record, and the flight from Houston to Chicago has a 50% on-time record. What is the probability that both flights will be on time? All we have to do is write both percents as decimals and multiply, and we get 0.45, which is only 45% of the time. Not terribly likely. When the outcome of one event affects the outcome of another event, the events are dependent events. For example, drawing a card from a deck, not returning it, then drawing a second card are dependent events because the drawing of the second card is dependent on the drawing of the first card. If two events, A and B, are dependent, then the probability of both events occurring is a product of probability of A and the probability of B after A occurs. At the school carnival, winners in the ring toss game are randomly given a prize from a bag that contains 4 sunglasses, 6 hairbrushes, and 5 keychains. 3 prizes are randomly drawn from the bag and not replaced. Find the probability of pulling out sunglasses, then hairbrush, then keychain. Okay, there are a total of 4 sunglasses out of originally 4 plus 6 is 10 plus 5 is 15 prizes. Then hairbrush. There are 6 hairbrushes, but we've taken 1 prize out, so now there are 14. And there are 5 keychains, and we've taken out 2 prizes, so now there are 13. And canceling is always a good idea with fractions. I can cancel the 4 and the 14. And I think that's all we can do. So 2 times 2 is 4 times 1 is 4 over 7 times 13 is 91. So of it happening in that specific order, our probability is 4 out of 91. Okay, same setup, but this time they want hairbrush, keychain. Okay, so there were 6 hairbrushes, so 6 out of total of 15 prizes. They took out 1, so now there are 5 hairbrushes out of 14 prizes. And keychain, we had 5 keychains, and now there are 13 prizes. And once again, we can cancel. Well, the 5 will cancel. Oh, and the 3 will cancel. And the 2 will cancel. And I think that's all we can cancel. So we have 1 times 5 is 5 over 7 times 13 is 91 again. So I guess we could say that outcome is slightly more likely. Okay, this time they want us to start with sunglasses, which we had 4 out of 15, and then hairbrush, which was 6 out of 14, and then not a keychain. Okay, we have 13 items left, and we've taken out 2, and there were 10 not keychains to start with, so 10 minus 2 leaves us 8 not keychains. And we can cancel again, cancel by 3, cancel by 2. And that looks like it. So this combination gives us an outcome that'll happen. 2 times 2 is 4, times 8 is 32 out of 455 times. For part C of example 2 printed in the book, the events for drawing a marble that is green and for drawing a marble that is not green are called complements. Consider the probabilities for drawing the third marble in their example. So the probability of green was 11 out of 38. Probability of not green would be 38 minus 11, or 27 out of 38. When you add them together, 11 plus 27 is 38 out of 38, which is 1. This is always true for any two complementary events. Events cannot occur at the same time are called mutually exclusive. Suppose you want to find the probability of rolling a 2 or a 4 on a die. Since a die cannot show both a 2 and a 4 at the same time, the events are mutually exclusive. If two events A and B are mutually exclusive, then the probability that either A or B occurs is the sum of their probabilities. The probability of A or B equals the probability of A plus the probability of B. Alfred is going to the Lakeshore Animal Shelter to pick a new pet. Today, the shelter has 8 dogs, 7 cats, and 5 rabbits available for adoption. If Alfred randomly picks an animal to adopt, because, there's no difference between a rabbit and a dog, what is the probability that the animal will be a cat or a dog? Well, the probability that we have a cat or a dog, there are 15 of those critters. Over the total number of critters we have are 20. So basic definition of probability is favorable over total, so 15 out of 20 would reduce to 3/4, or 75%. Suppose you wanted to find the probability of randomly selecting an ace or a spade from a standard deck of cards. Since it is possible to draw a card that is both an ace and a spade, these events are not mutually exclusive. They are called inclusive events. If two events A and B are inclusive, then the probability that either A or B occurs is the sum of their probabilities decreased by the probability of both occurring. So the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. A dog has just given birth to a litter of 9 puppies. There are 3 brown females, 2 brown males, 1 mixed color female, and 3 mixed colored males. If you chose a puppy at random from the litter, what is the probability the puppy will be male or mixed color? A Venn diagram works beautifully on these. Okay, first of all, we're going to start with the part that works for both categories. It says there are 3 mixed color males, and there was 1 mixed color female. So that's mixed color but not male. And it says that there are 2 brown males. So they want to know what the probability that a puppy will be male or mixed color. So altogether, if we add up our categories, 2 plus 3 plus 1, we've got a total of 6 puppies accounted for out of all 9 puppies in the litter. So that's going to reduce by 3 to 2/3. For independent events, use probability of A and B equals probability of A times B. For dependent events, use probability of A and B equals the probability of A times the probability of B following A, so things decrease. For mutually exclusive events, use the probability of A or B equals the probability of A plus the probability of B. For inclusive events, use the probability of A or B equals the probability of A plus the probability of B minus the probability of A plus B. I'd rather do it in a Venn diagram.